Hey everybody, this is a weird little insert video that goes along with like 10 other parts for one particular problem. So if you're watching this one by itself, you might want to go back and try problems 9.15.1 through 8 before you get into 9.15.9 in the Collaborative Statistics textbook. Okay, so the idea is you've already kind of crunched the numbers on this one. Your hypotheses are up here. You're checking, is the proportion appear to be less than 9.5%, or is it about the same, or arguably no different than 9.5%? These are the results of the test. You've got a p-value. I'm going to make that really big. I made it capital, but let's make it really big so you can see the p-value of 20% and a z-test statistic of about -0.85. Okay, so what they want us to do is to draw a curve, labeling a horizontal axis, sketching the p-value region, and also slapping p-hat up there, which I think is a fantastic idea. Okay, so as far as a horizontal axis, we'll draw it right here. We know we're assuming a bell curve. We're assuming a bell curve because we satisfied the binomial and we're not doing this non-parametrically, so we're going to use that one prop z test, z implying standard normal distribution. Okay, on this curve, which is the null hypothesis curve, we're going to have a center at 0.095. Okay? Now, if you eyeball this curve, 2 standard deviations is going to be roughly down about here. But this is a one-tailed test. So, we're going to slap our critical region, if you will, somewhere over here. And I'm not entirely sure where that is, and it doesn't matter. You'll see that in a minute. But somewhere out in here is going to be that beautiful 5% region. If our data landed out there, then we're going to stop and say, something interesting just happened. We know that something is at work, but it appears that the rate in this sample is indicative that the population that it's drawn from is actually lower than the preconceived notion of 9.5%. Now the question is, 7% was the p-hat, little p-hat value was 7%, or 7 in 100. Okay? The question is, where did that land? Now, here's the deal. Here's the deal. Rather than put that up first, I'm going to put that up first. Okay? We're trying to see if we believe this. This is going to be a left-tailed test, which means the shading is going to be starting at a given point and shading to the left. Since it's only 20% area that's shaded, I know it has to be left of 9.5%. I also know that because 7% is left of 9.5%. But the question is, where is it along this curve? That's the question, isn't it? So what I can do is, I can do a little bit of remembering from Math 243. I know that within 1 standard deviation is roughly 2/3 of the data. So that's going to be about 70%. That's going to be about 70%, which means this is about, I'm going to call it 35, just to eyeball it. 35%, that puts 15% down here. So roughly 15% is going to be to there. Take it up to about here, and that makes about 20%. That's my p-value. Let me ask you a question. That p-value, is that bigger than 5%? Yes. P-value is bigger than 5%. Who do we believe? We have no reason not to believe that. No reason not to believe that. There's no evidence that shows that it's below 9.5%. Because our 7% p-hat value corresponding with this -0.85 is going to land right about there. That's a percentage axis. That would correspond to -0.85 standard deviations down, which kind of goes with what I was saying before about how that right there is -1, up a little bit, -0.85. So there's your graph, there's your p-value shaded, there's your p-hat value. Pretty much everything you need. Your TI, of course, does all this for you. It just doesn't do it as label-y and as colorfully. So you get the same information, you get it quicker. I like this because you can actually put some context to it. Hope that helped.